bit. We're going to shift now to scale creation. And so just going to show you some slides and talk through some concepts. I'm not going to actually have you build scales today, but we're going to link this together with some of the things that you heard over the last couple of days with statistics and how those are now related to the development of measures, how we can use that information, and then some logic on the general ideas behind scale creation. And our example will run with a couple of the actual DSPG projects through that. More so, this is a conceptual stuff. So nothing you're going to need here. We're not going to be doing any R with this just yet. That's more of a down the road as we have data available kind of thing. I didn't think it was fair to put you all in breakout rooms and give you 30 minutes to create a valid, useful scale to measure something. It seemed a little unreasonable. So I want to talk kind of conceptual based, some detail about the general logic of scale creation and some applications, but also want you guys to chat back with some ideas, questions, things like that. Coming out of the social sciences, some of this will seem familiar to you if you have a background in social sciences. If not, some of this may seem incredibly unusual. We'll be talking about invisible things that they exist, but you can't actually touch them or see them, and how to measure those types of things. So in terms of terminology, labeled as scale creation, index creation, all interchangeable terms. Some key points, though, that are important is that when we're talking about scales, they're made up of items. Indicators make up indices. So an indicator is probably something very familiar to you, just a general single piece of information, a single one unit piece of a puzzle. So an indicator could be per capita income is an indicator. It's one value. An index then is a collection of those items or indicators. And what you're trying to do with an index then is combine individual bits of information that all form a piece of a puzzle into most of the full puzzle that you're trying to solve. And when I say most of the puzzle, what you'll quickly realize is that no measure is ever perfect. All measures are going to be missing some information. People will argue extensively about the nature of two measures created to assess the same thing. But keep in mind that what you're trying to do generally is go from a single piece of information to a much larger picture related to the thing you're trying to measure. OECD actually defines composite indicators this way. Composite indicator formed of indicators to create an index, which is true. It's a little confusing, but just keep in mind what you're trying to do is take a single piece of information, combine it with other single pieces of information to create a more full picture or representation of what it is you're trying to measure or assess. So here's a quick conceptual example. Measuring commuting to work, although most of us don't do that, and I still am commuting most days, so this is on my mind. Typically, there's a long literature actually in connecting things like commuting to stress levels, happiness, well-being, all a host of things. Daily commutes are typically a constant sort of stress for folks. And so if you ask somebody, well, how do you measure commuting to work? Very simply, how many miles you drive. That's a great indicator of commuting. Obviously, somebody who has a 5-minute drive to work spends more time commuting than somebody with a 20-mile drive to work, but therein lies the second piece of information. Distance is one thing, time is another. My drive to work here in Iowa is about 20 minutes. and it's 17 or 18 miles. When I lived in Southern California, my drive to work was about 20 miles and it took an hour and a half. So mileage and time are not necessarily the same pieces of information. Time is a great index then, or an indicator of commuting that is related to mileage, but not exactly interchangeable with mileage. Another piece of the commuting puzzle, density of traffic. Much less stressful to drive on a country road than it is to drive on a 6-lane highway, assuming there's other traffic on the road in one place or the other. I will tell you that getting behind a tractor, it is a little bit, I won't say stressful, it throws a wrench in things, but density, how many other vehicles are on the road with you? Average speed, again, related to time and mileage, but slightly different. Anybody who's lived in a big city and experienced gridlock on a highway knows that in those moments, you would be thankful to just be moving at 2 miles an hour consistently, rather than starting, stopping, starting, stopping. Making continual progress feels better than just sitting there, going and then sitting there. So another piece of the puzzle. At this point, we've all made the assumption that someone's driving to work. So method of transportation. If you take the bus, a subway, a train as your commuting method, none of this might matter. It might all boil down to things like time. How long am I on the train? How long am I on the bus? Some of the best naps I ever got in grad school were on the bus. It was fantastic not to have to drive to work those days. Finished studying at 4 o'clock in the morning for an exam at 8, and the bus ride was actually an enjoyable experience. So that's an important piece of the commuting puzzle as well. Next, cost. How much does it cost to commute? Maybe you do take the subway, and maybe that costs a couple dollars a day. Maybe you do drive to work in a privately owned vehicle, and that has expenses related to it as well. That also falls back to things like traffic density. The longer you sit in traffic with the engine idling, the more gasoline you're burning than if you're traveling at an optimal speed for the vehicle. So there's an actual financial cost component to commuting. There's a time cost. How much time are you losing? Most of the folks that I know that are now working from home are adamant that they are now working an extra 45 minutes to an hour a day because they don't have to get in the car and drive to work. And so they're being more productive. They're getting more done without that break on both ends of the day. It's faster to get into the routine of the day's work, easier to stretch out the end of the day's work, and so forth. So there's also a time cost component. Another piece that to me is important is the aesthetic value of the road I travel. My current commute is through farmland, country roads, most of the year. So at least 3 times a week, on average, I would say I get to see something in the realm of wildlife that I don't get to see at my house. I might see a deer running through a cornfield. I might see birds fly out of the drainage ditches. To me, those things are enjoyable. So I actually like my drive into work from an aesthetically pleasing, relaxing standpoint. That might not be important to most people. Most people might want to just sit there on the train, earbuds in, reading a book. But does the commute that you engage in have some sort of value to you as an individual that isn't necessarily driven by mileage, time, density, speed? So these are a whole bunch of related pieces of the commuting puzzle. If you had to measure commuting, what other things might you consider in terms of these individual indicators? What other indicators can you think of? Shoot some ideas through chat. I know somebody has some ideas. Nobody's going to give me anything about commuting. So I've captured the entire construct of commuting. I'll believe that. How many days per week? How easy is it to get to the major roads you need to commute on? Stoplights, absolutely. Fuel prices. you're seeing the issue. How many coffee shops are on the way? Is that part of the time, right? That's the only time I get quiet, peace and quiet to go get a cup of coffee is on my drive to work. Comfort of the vehicle, parking ability. So you're seeing this now, right? That we're talking about a commute that if somebody asked you 5-10 minutes ago, how do you measure commuting? Mileage, how long you're in the car. But now we see that I have what, 6-7 things here. You've given me 6 or 7 more. There's a huge construct or component, a piece of what is commuting that can be measured with multiple indicators that are all potentially related to each other in some way, but are all not exactly the same thing, right? So this is what we're talking about in terms of measuring constructs and creating indices. Sorry, go ahead.
E mi dici che così invia la mail. Leggi.
Is somebody, I could barely hear that. Is somebody asking something? No? Okay. So, indices. We have these indicators. Why then create indices or indexes or scales? All the same thing. Indices, plural of index, index, a combination of indicators, scale, combination of items. Logically, one of the primary reasons we want to use things like indicators to create indices is that we get a better assessment or a better measurement of what it is we're trying to capture. As I said, if you have a background in the social sciences, you would undoubtedly at some point have heard the terms psychometrics or classic measurement theory. Both dominant models in the social sciences, although there are others, but the ideas for measurement, like commuting time, like constructs, stem from both of those intertwined subfields. The ideas underlying better measurement then, first being things like construct coverage. Some constructs are pretty easy to identify, pretty easy to define, and then also pretty easy to measure. There's not a lot of argument amongst people about what height is, what physical height is. We have a definition. There might be some metric arguments, whether it's a centimeter, whether it's inch, whether it's something else, but we all agree essentially that height is some distance vertically from some point on typically the ground. And so we also have tools to measure height. We have pretty calibrated tools to measure height. So we don't have a lot of disagreement about what the construct of height is. You're either tall, average size, slightly shorter, something's high off the ground, something's low off the ground. Same concept. Height is well defined, well identified, well measured, pretty simple. But if I ask you the same thing about what well-being is it as easy to define as height? What is well-being? Well, it's way more complicated than commuting time or commuting mileage, right? Well-being is a construct that we may not even all agree on what it is. We sure can't see it. You can't see somebody's well-being. We infer it from characteristics about people, their attitudes, their moods, their behaviors. But all of those things fall into the construct of well-being. How do we measure it then? The complexity of the construct is what drives this idea behind indices or index development. We can't capture well-being necessarily well with one thing, with one indicator. From a psychometric standpoint or a classic measurement theory standpoint, sensitivity. If we use one single indicator to assess a construct, there's a high likelihood we won't have much variability in that assessment. You guys learned about variance over the last couple of days. It's the driving force of what we do, right? Things have to be variable. And so sensitivity, if you have multiple indices or indicators on an index, the likelihood of values differing is higher. There's going to be variability or discrimination or sensitivity, whichever term you really like. But rather than just asking somebody a yes or no question, right? Are you doing well today? yes or no. You get only a slight differentiation between people versus having them rate how well they're doing today, versus having them rate how well they're doing on 5 different dimensions today. You see the point of variability becoming a driving force behind the construction of indices. Consistency is similar in terms of topic and relation to variability, in that if you ask somebody, are they having a good day or a bad day, that's likely to change from day to day, from yes to no, no to yes, no, no, yes, yes, if you ask over 5 days. But if you ask them to rate how well they're doing over that same 5 days, you're likely to get change. So some days might be a 2, some might be a 4, but you're going to get a much smoother picture of their overall week in terms of how they're doing generally. Right? So consistency in response, sensitivity in information collected, tied into the construct that you're trying to measure is complexity. As a great example, just because it happens to me all the time, do any baking, you know that temperature cooking, not just cake baking and things like that, but if you do any cooking, you know that temperature is a pretty important thing. I notoriously buy cheap thermometers. I get cheap thermometers because I lose them or break them, so I just buy cheap ones. Thinking about that situation, suppose you have a thermometer that you know is inaccurate. Cheap thermometers are never very accurate. And you know it's off by somewhere between 5 degrees low and 5 degrees high every time you take a reading. In the absence of running out and buying a better thermometer, what might you do if you're trying to figure out how hot something is? What's a logical thing you might do? See if anybody will tell me, don't tell me go buy a new thermometer. If you need something to be 175 degrees and you know that your thermometer's inconsistent, what do? Take multiple readings. Absolutely. This is exactly the classic measurement theory justification for why we like indices or scales rather than single indicators. No single indicator is perfectly accurate when you're talking about trying to assess complex constructs. And so just asking somebody how you're doing today isn't going to be an error-free, perfectly exact assessment of how they're actually doing today. It might be how they're doing right now. It might be how they were doing an hour ago. It might only be relative to the context you're in, how they're doing during this talk. That might not be the question you're asking. So from a classic measurement perspective, every item or indicator that we use has some error in it. By using multiple indicators or items, we smooth that error out. We get a better picture of the actual values. Last bit about why creating indices is important or why creating scales is important is that the things we're typically trying to measure are complicated, are complex. I mentioned we probably don't all necessarily agree exactly on what well-being is. You can't see it. It's unobservable. It's complex. It's multifaceted. So indices are usually driven by theory, a theoretical model of what it is that we're actually trying to measure. Trying to get PowerPoint to move to the next slide. There we go. So here's a real example from the sociology and psychology literatures of the late 90s. Pivotal social science piece of work that ended up in a very prestigious place and drove a lot of research over the next decade that I was involved with, that I was familiar with. This idea of community characteristics and violent crime in communities. And so long regarded in the literature that if you live in communities that have what it's called concentrated disadvantage, usually tied strongly to things like poverty. First off, you might be asking, how do you measure concentrated disadvantage? It's not just income, right? It's poor transportation, it's joblessness, limited opportunities for new jobs, no businesses, those sorts of things. Strongly related, solidly, I would say solidly, moderately related to violent crime rates, right? In areas of really high disadvantage, violent crime tended to be higher. This is well established in the 80s, 70s, going back. Residential instability is also strongly related with violent crime. The argument less clear why, other than transient populace moving in and out of places, coupled with concentrated disadvantage, and oftentimes related to concentrated disadvantage. People move away when there are no opportunities if they can. So both of these things is connected with violent crime. Sampson, Raudenbush, and Earls were among the first who attempted to try and figure out why this happens, why there's this relationship, this correlation. You guys learned about those yesterday. These positive relationships between disadvantage and instability and violent crime. And so from a theoretical point of view, they argue that there's a construct called collective efficacy. Right here in the middle, it's invisible. That's why it's in dotted lines. You can't see it. And it's really this collective efficacy construct that is related to violent crime. And concentrated disadvantage, residential instability, actually only relate to violent crime through their relationships with collective efficacy. So if you have high concentrated disadvantage, collective efficacy should be lower, the negative sign. Lower efficacy related to higher crime, negative relationships, right? Inverse relationships. So this is their theoretical model. Well, the next step then is defining collective efficacy. What is it? Well, it's a multidimensional construct. And it just means that it's not a single thing. There are pieces to it, much like our commuting example. It's a multidimensional construct of other multiple dimensional constructs. So from a theoretical perspective, collective efficacy is the combination of informal social control and social cohesion. Those things themselves are multidimensional constructs, operationalized or defined by things like residential tenure, home ownership, willingness to intervene when things are going bad in the neighborhood, community, things like graffiti, crime, loitering, those sorts of things. Social cohesion, on the other hand, relates to things like trusting your neighbors, everybody having an attitude toward the common good of the neighborhood and agency towards pursuing that. Strong social ties in the neighborhood, shared values, positive relationships with your neighbors. Are you willing to help them? Are you willing to loan them tools, bring them food, things of that nature? So you can see that our indicators, our single indicators, are all down here. Home ownership, well, that's something we can grab pretty easily from something like the Census Bureau or the ACS. What percentage of residences in a particular community are owned versus rented? Sure. Residential tenure, that's an indicator. These things, willingness to intervene is a little bit more complicated. There could be multiple indicators here, but those combined form this informal social control construct. Control in the sense that the community is willing to enact to keep the peace, keep their community together. Social cohesion is made up of multiple things. The combination of informal social control and social cohesion then create this idea of collective efficacy. All of these items then are indicators that are being combined in indexes or indices. Those indices then are potentially being even further combined into an index of collective efficacy. All of these things have theoretical relationships among them. Why would residential tenure be important? In the informal social control side of things, well, the longer people live in a neighborhood, the more likely they are to develop social ties with other people in their neighborhood on the purple side, have positive relationships with their neighbors. Okay, so one is required for the other to develop. Home ownership, why is that important? Well, when the majority of folks in a community own their homes, they have an interest in the neighborhood being maintained, being a nice place to live, being clean kept, agency towards the common good. So there are theoretical relationships across these dimensions that connect them, but they're not the same things. From that general idea then, there are indices everywhere. If you just go look for them, you will find them. Here are a couple of ones that are interesting to me. The index of deep disadvantage. This is now, it's gone deeper than disadvantage. It's deep disadvantage. And this comes out of the University of Michigan. It's a multidimensional index that combines information about income, physical health, and social mobility. Each of those things are multiple indicator indexes. Income uses a series of poverty indicators, so things like per capita income, joblessness, education, percentage of the population in a particular area less than a high school diploma, and so forth. Combines multiple indicators of physical health, life expectancy, birth weights, other things like obesity rates, all sorts of things like that. And then there's a component of social mobility. How much do people within the same generation move in and out of communities? Indicators of residential stability and things of that nature. The combination of those multiple indicators into these three bins, if you want to think about income, health, and social mobility as buckets or bins, and then the combination of those three bins into a single index is applied across the United States in this case. And this happens to be the 10 deepestly disadvantaged communities of, I think this was 2019. And it's striking that it's really only 2 states. Very strange. They have explanations for why it's these areas in South Dakota and Mississippi, theoretically based answers why. And so it's sort of interesting that this index is catching very specific places in the country. On this disadvantage index, it's very likely the case that the areas in South Dakota are scoring low for slightly different reasons than the areas in Mississippi. One could be more impoverished than the other. Life expectancy and health might be worse than one or the other. A similar index that is not so downtrodden and sad is Gallup's Share Care, and Well-Being Index. This has been around for quite a while. I think they teamed up in 2008 officially to do this. This is all done with survey data. They actually assess people, and they have 5 buckets of area that they like to investigate. So they're talking about well-being in terms of your job, your relationships, obviously financial situation, the neighborhood you live in, your community, and physical well-being, your health. So you can see some parallels between the disadvantage index and the well-being index, but the same general idea. So within career, there's multiple items that index your career well-being. There's multiple indicators of your social well-being, financial, physical, and community. Those indicators are then combined into these 5 buckets. Those are then combined into a single index of global well-being. I think these might be 2018 data, but you can see for each state, they've color-coded, it's all green, so I don't know how helpful that is, but into quintiles. So the best states, the worst, and the lowest states, and everybody in between, where they rank on this global index of well-being. What's important to note here that is if they had mapped each of the 5 pieces of that well-being index, we might see a very different map. People might be very satisfied with their careers in parts of the country and very dissatisfied with their careers in other parts of the country that may not exactly map onto this global index picture. So where does this all fall in with the DSPG program? I'm sure some of you've all probably heard some of this to some extent by now, but a couple of the projects that are going on, 2 here at Iowa and 1 at Virginia, are dealing with creating these indices of community capitals. And the community capitals model is a theoretical model that looks at the, I want to say resources is a general loose term, that communities possess that they can invest in improving and thriving those communities. Within that community capital, then, there are subdomains, built capital, financial capital, natural capital, cultural capital, human, political, and social capital. And so there are different things in each of these 7 buckets of capital. Natural capital is what you might think, natural resources. Built capital might be infrastructure, busing systems. Financial capital, pretty straightforward. But these things are all pieces of the community capital puzzle. And each of these then is its own index. There's a natural capital index. There should be a built capital index. So if we take any one of them, social capital happens to be one of the projects I'm working on here in Iowa. How do you measure social capital of a community? What indicator do you use? Well, there's no way a single indicator can cover what social capital encompasses. This is an example of a theoretical model, the NBS model. And it's just one example of others that are out there. It's an interesting one to me because it's large and it actually combines some other submodels in the literature on social capital. The NBS model starts off with the goal of measuring social capital. That's a great goal. Their model then breaks things down into 3 sub-dimensions: a structural component, a relational component, and a cognitive or thinking, what I would call a person component, an individual component. Within each of them then is subdomains or subcomponents. That should have happened. So we have, say, for example, in the structural dimension, network structures, civic engagement. Within each of those, then, you can see that there are indicators: network diversity, network density. How many people do you know? How many people do you talk to on a weekly basis? Within any one of those mid-level components, social cohesion. How close is your neighborhood? How together are neighbors in your community? Going one level down to the bottom of this, then, additional buckets to think about. And this is where they tie in one of the dominant models, the network perspective of social capital, another theoretical position that focuses entirely on social networks as an indicator of social capital, where you have different types of relationships, focusing only on the relationships individuals have. So you have bonding relationships, and these would be things like your friends and family, close, similar, others, shared values, those sorts of things. But then you have bridging relationships. So that's connections to people that are less similar to you. Might be coworkers, might be colleagues in school, might be folks that you've met from other places. And then you have linking ties. And these are typically hierarchical relationships. So this might be an employer, this might be connections to city council folks. Again, this is an entire theory, the network perspective of social capital, that in the larger NBS model is a very small single piece of this massive index of social capital, a theoretical driver of what is potentially tens of indicators in different subdomains to create a potentially single index of social capital. So the logic behind why we do it and how you might go about starting to do it is great. How do you physically go about constructing indices? There are some things that need to be solved along the way. After you've defined what it is you're going to use to create the index. So what conceptual map are you going to follow to define social capital or anything else you're assessing? You go find the data that has it. Now the physical constructing of the index. What do? One of the first challenges you typically face is scaling an index. In our commuting example, we had things like time, miles, aesthetic value, doesn't really have a number, mode of transportation. How do you combine all that? You might have things that are answered in dichotomous, categorical responses. You might have some scale type data responses. I think Heike talked to you all about ordinal scales and Likert type scales and things like that. You might have monetary figures, mileage, time. How do you combine it all together? You just add it all up, right? And the yes and no is equal to, it's impossible to just add it up. Another problem that occurs even if things in their raw metrics happen to be similar, right? So let's say we're using things like time or percentages are a common one. What percentage of the people spend more than this amount of time drive over this amount of time? They're all in the same metric. Percentages can be combined with other percentages pretty easily, but distributional differences might occur, right? So you might have something like this picture on the bottom right, where certain distributions appear normal. Right? There's a percentage that ranges from 10 to 90%, and everybody's in between there. Great. Oftentimes percentages will not appear normal. They will actually tail off. No community is at 0. No community is at 100. Maybe there are communities at 0, but the scale only goes up in a particular set of communities to 60%. So what do you do with distributional differences, where you can't necessarily say that the point on one scale is the same as the point on another scale, even though they have the same metric, right? So a couple of common possible solutions then are to standardize your measures, your indicators, and standardization being just using the mean and the standard deviation to equate scales, remove a constant value from each one to set them both at the same point. Typically setting the mean at a 0 point and then deviation around it. Another popular way of doing this without standardization, particularly when you see some things like this, where standardization doesn't make a lot of sense. It can be difficult to standardize some distributions. And it might be inaccurate to try and set the midpoints at the midpoints and so forth. If the midpoints are dramatically diverse, even if the scale for 2 items happens to be the same metric. Another approach is what's called end-tiling. And you probably have heard of things like quartiles, quintiles, decitiles. End-tiling just means a number and distinctions in a distribution. This link that I will click on if you want to join. You may have seen this, but I will post it in the chat. I wanted to jump to this. Are some indicators that have been created in relation to the, if I can get to it. There we go. In relation to the Gates grants that are funding some of the DSPG work this summer. And share my screen back with you to show. And these are some indexes that were created to measure barriers to remote working, remote education, and remote healthcare, particularly mental health care. And so the logic that we just talked about is consistent, where there are indicators combined into indexes. How do you measure access to healthcare, telehealthcare particularly, with a single variable? You can't necessarily. So that's what these maps are showing. We can select remote education, we could select remote work, telehealth, we could select states out. And these are that kind of global index, right? We can hover over, do all that fun stuff of each of those. But what's really neat here from an index construction standpoint is that we can actually get down to one level below that and look at the indicators, the pieces, the indicators, the individual pieces of the puzzle that make up telework barriers, tele-education barriers. And so here we can see that there's percent households without internet access. That's important, but does it do you any good if you happen to live in an area that has a high prevalence of internet access, but you don't have a computer? 2 different pieces of the same puzzle. In terms of how they equated these things, you can see if you hover over quartiles, right? So there's a minimum, a lower fence, quartile 1, the median, quartile 3, and so forth. And in order to essentially equate the scaling across these different indexes, that's one approach. Rather than standardization, break into equal groups of the lowest 20%, the next 20%, the mid 20%, the upper 80%, and then all the way to 100%, and locate observations, in this case, counties, towns, could be people. You locate them in those distributions along their area, is a way to put it. And so if we think about different shaped distributions, you could have something that looks very J-shaped versus something that looks more like a normal bell curve. If you locate people in the upper 40th percentile in each of those distributions, that's directly comparable. It doesn't really matter what the scaling is of the original indicator. It doesn't really matter what the distributional shape is. If you're in the 80th percentile on one indicator and the 80th percentile in another, that's a comparable location. This is a pretty cool approach to equating different types of information. So definitely play around with those when you have time. All right, so hopefully this is back up, being very unusual. There we go. So is PowerPoint screen back up for all of you?
Yes.
Great. My screen sharing does not work particularly user-friendly. So a couple of things to consider then. How are you going to combine information? Which approach is going to be the most interpretable? The Gates measures that we just looked at were quintiled, so there were 5 breaks. That's not necessarily what you would do in every situation. Kind of depends on how full the data is, how refined you want to be. Might be decitiles, so 10%, 10 to 20%, 20 to 30, and so forth. Some things that you can do to equate metricing, which is an important step in scaling an index. Weighting indices. The most common approach in index construction, scale construction, is what's called unit weighting. And here you're just saying that however many indicators, individual pieces of information you're combining, they all exert the same influence on the construct that you're measuring. So typically we use 1. So 1 times item 1 plus 1 times item 2 and so on. Unit weighting just means that each indicator that makes up the index has equal value or equal overlap with the construct you're trying to measure. While it's the most common thing that's typically done, and it usually makes sense to do, it's not necessarily a rule. Differential weighting happens in some situations, and typically differential weighting is, when it occurs, is a theory-driven or logic-driven decision. It's where you actually will, let's say you have 5 indicators that are going into this index you're creating. You might decide that, well, in the example we were just looking at, maybe not having access to a computer is slightly more of a barrier than not having internet access at home. You might reach the decision that one thing in your pool of indicators actually should have a little bit more presence in terms of the index you're creating than the others. One measure I'm familiar with is something called the Euroqual, which is a worldwide measure of physical health that's used. It has a unit weighting score that you can compute, but then it also has a very complicated quality of life score that can be computed, where they do this. Certain components of your physical and mental well-being are scored higher or contribute more towards the overall score than other pieces of information. Again, it doesn't happen terribly often, but differential weighting can be something very useful. if you think through and decide that, well, okay, a couple of my indicators for this construct I'm trying to measure are more focal than the others, more important. My FICO score graphic here, sometimes differential weighting is not well thought through and doesn't make any sense. But a FICO score is a great example that most people are familiar with about how differential weighting works. Obviously, though, they don't tell you how they index each of those 5 pieces, but the logic is the same, right? That most of your FICO score is dominated by how much you owe creditors and how well you've paid them in the past. Severely less weight, about half the weight essentially, for your credit mix and the amount of new credit you've pursued. To me, I don't know, I would upweight length of credit history a little bit more than that. If you've had credit for a long time and you have a high payment history and you don't owe that much, that should pretty much dominate your credit score. So just an example of this idea of differential weighting. The last type of approach you can use in constructing weights is what's called optimally weighting. And in optimally weighting indices, the weights are completely driven by the numbers, by the empirical data you're using. Both of those indexes we looked at earlier, the index of deep disadvantage and the Gallup share care measure of well-being, are both optimally weighted indices. One uses a procedure called principal components analysis that you might hear about later this summer. The other uses a very similar approach, slightly different, called factor analysis. And what they do there is they take all of those individual indicators and fit a statistical model that essentially capitalizes on the optimal scoring, differential weighting of each indicator to create the most consistent, I'd say consistent is probably the best word, measure of the construct. There's 3 general approaches. In terms of consistency then, once you've created an index, what do? You evaluate it. The key part about all of this is to come up with an index that has some evidence behind it being useful. There's 2 key components of evaluating indices. One, the first one we'll talk about, is what's called reliability. And reliability is exactly what it sounds like. How consistent is the measure? My baking thermometers example, poor reliability. Different measure every time you use it. And that is not consistent. We're not saying exactly the same measure or the exact same assessment, like a ruler. You get the exact same value on a ruler if you apply it to the same piece of paper twice. That's not exactly what we're talking about here, but the same idea. That the scores won't necessarily, or the values on the indicators won't necessarily be exactly the same, but they should be very similar across different times of assessment or across different assessment groups. And so it's not the case that scores can't change. It's just that the ranking of scores will remain reasonably consistent. So in the example I've got over there, say you ask somebody a question twice, and these are just rankings, 1 through 10. There's ties the second time. That R is the correlation that you've heard about for the last couple of days. It's relatively high. That's a pretty decent correlation. So we would say that the rank is maintained, that the assessment is reasonably consistent over applications or administrations. That same logic then falls to the indicators themselves, the single piece of information, the collection of them. They should also be related to one another. You guys heard about the linear model yesterday. That's what we're talking about here. There should be associations between the components of commuting time. They should be correlated with each other. Ideally, they should be highly correlated with each other to the degree that they're all supposed to be measures of the same theoretical construct. If we're measuring commuting time, those indicators of commuting time should be strongly related. If we're measuring well-being, indicators of well-being should be strongly related. Another way and a consistent way of thinking about this reliability issue is partitioning of variability. If we have 10 items or 10 indicators, and we're going to create a single index from them, scores on that index will be variable across persons, communities, towns, counties, whatever aggregation level we're collecting the data at, there will be variability in that index score. The variability in that index score in relation to the total amount of variability in the 10 individual pieces of information should be high. So you guys heard about R squared, right? The proportion of explained variance over error variance, essentially. Same idea here, conceptually, is that the reason why the items vary is because of the construct you're trying to measure. The construct actually explains a large proportion of the total variability in the items relative to the leftover unexplained or error variance in the items. All of the same idea behind consistency or reliability of a measure. The second big piece in evaluating indices, once you've created them, scales, indices, whichever you prefer, is accuracy. And this is where we get into the topic of validity. I think you guys heard a couple of weeks ago that in social sciences, there are hundreds of different validities. There are tons of different validities. We're going to talk about just these few today. The key point about validity and reliability is they're connected. Reliability, consistency is a necessary but not sufficient condition of accuracy. So if you're trying to measure something well, you have to have an instrument that reads the same thing every time. But I can take an instrument that reads the same thing every time, and it may not be an accurate measure of what I'm trying to assess. So we said height is pretty easy to measure, and we have accurate, consistent ways of doing that. I can apply a ruler to your height and get the same reading every time, but that probably doesn't have any useful information to add to my index of your well-being. It's a reliable measure, it just is not an accurate or relevant measure. So you can have reliable, high evidence of reliability and have a measure that's completely invalid or inaccurate, but you cannot have a valid measure that's not also reliable. So some key types of validity in terms of evaluating indices. A lot of different ways to kind of combine these into hierarchies and substructures and subtopics of validity. But the key three, I think, are these. It's just content validity, construct validity, and a term called face validity. Content validity is a subjective theoretical issue. Domain coverage. If I'm trying to measure your well-being, and I'm going to use these 65 indicators to do that I've broken down into these 10 different subdomains of well-being, are those indicators fully covering what it is I'm attempting to measure? Do I have domain coverage? I might not be intending to measure an entire domain. We go back and look at that social capitalism model. I might only be interested in the networks component. So then, I heard somebody. So then I might only, why does it keep doing that to me? Be interested in a sub portion of the construct. And so then are my indicators covering that portion of the domain? And again, this is a subjective piece of information that's usually dealt with through discussion, thinking, logic, and that sort of thing. When we move to construct validity, this is where you actually have an objective set of things you can do and evidence you can obtain to determine that the construct measure you've created or the index you've created is valid. So within that, there's a number of different types of things, but we'll just talk about these four quickly. Convergent, divergent validity, and concurrent and predictive validity. They're sort of opposite ends of the same poles, but not quite. Convergent validity is really just that. Does the index you created converge with things it should converge with? So if I've developed a well-being index, does it relate to things also related to well-being? If I created a well-being index, does that relate to your physical health? It should. Does it relate to your social relationships? It should. They might not be part of the index I've created, but theoretically, if you score high on well-being, you're generally satisfied with a number of other things in your life. Convergent validity. The index you created, does it relate the way it should to other things that are like it? And the reverse of that then is divergent validity. Does my index not relate to things it shouldn't relate to? So if I'm creating a well-being index, it shouldn't be completely repetitive with something like your salary. It's supposed to be measuring more than that. There should be a potential relationship there, just not a very strong one. Alternatively, my well-being index shouldn't relate to things that have nothing to do with well-being. I would expect the correlation between my well-being index and your shoe size to be 0 or thereabouts, roughly, right? Random process. So does my index converge, relate to things it should, and diverge from or not relate to things it shouldn't? This is done through correlational analyses, typically, maybe regression analyses. The next two pieces, concurrent and predictive validity, are related to regression models that you heard about yesterday. Concurrent validity means that my index I've created, the scores on it, they should relate to certain things I'm thinking that are criteria now. So if I'm creating this well-being index or this social capital index, does it relate to other measures of community success or individual health now? So thriving communities now, do they have, we would expect them to have high levels of social capital on this index for creating concurrently. Additional piece of evidence in terms of validity then is predictive validity. And that is exactly what you would think. Does the index that I'm working with now predict things that haven't happened yet? So does your level of well-being now relate to longevity, health in old age, satisfaction in retirement? I'm assuming none of you have retired yet. Does my index relate to things it should relate to that haven't happened yet when they do happen, right? It's called prospective analysis. Does the index of social capital that I'm developing now, does it, if I take the values on it now, do they relate positively to economic thriving 3 years from now in those communities where we've assessed it? Predictive validity. The last piece of validity that depends on who you talk to. Some people will deny it furiously. It's something called face validity. And essentially what that means is, does your index look like it's measuring what you said it was measuring? I have a great example offline if you want something that has absolutely no face validity, but is a valid measure of something important. It happens. And scientifically, face validity is given much less emphasis. The reason I bring it up here is because typically the work we're doing as data scientists, and particularly in the Data Science for the Public Good program, is you're dealing with stakeholders. You're dealing with people and organizations that you're going to present this information to. In my work as an evaluator, I can tell you that face validity, while it's the least of the scientifically rigorous types of validity, is often a very important component to go in and explain to somebody, general public, if you're making a public-facing dashboard or website, that my measure of social capital or my measure of community well-being or my measure of commute times, whatever it is I'm creating this index of, doesn't have things on it that look strange. Doesn't have things on it that clearly shouldn't be there. So if I tell you that my well-being index does use your shoe size, whether you're right or left-handed, and the color of your hair, that's immediately going to lower your perception of the accuracy of that index. So face validity is important in the sense that you're going to be doing a public-facing or at least a stakeholder-facing presentation where you don't want them looking at you going, that makes no sense why you've included that. So it's more of an aesthetic quality of the measure, but it is important to the people you're typically going to be working with on projects. Questions about index construction, scale construction, methodologies to do those sorts of things? All right. Well, that's all I have for you on scale construction, but definitely if you you run into specific questions, I know there's at least one other team working on this type of project, feel free to shoot me an email. Otherwise, thank you for the 4 days I've spent with you as a group. Hope it was beneficial.